Okay, so I will be talking about the research putting the brakes on child derailment with positive train control. And my name is Justin Delgado. So the reason I chose trains was because it's one of the most related subjects to cars. They are basically oversized car engines that run on rails. Cars have engines like V12, V16s, V24s. Trains have engines like V12, V16s, and V24s. Cars have V6s, V4s, V8s, and V12s. And primarily for race cars, they use V16s. And what started my likeness for cars was Paul Walker and playing Need for Speed games. And all around, it was hanging out with people who know about cars, like my dad, my brother, and other friends. Does anybody know what this train is? This is a freight train which delivers supplies across the country. And other countries have different models of trains. Anyone? So this is a passenger train that delivers passengers across countries. And anyone? No one? So this is a maglev train in Japan, which I think only Japan has this for now. And this, nothing. So this is a monorail, which is in certain areas that are maybe you can't travel on certain grounds, so they bring it up in the air. And I'm guessing no one pretty much know this. This is a bullet train, which travels in high populated areas to move business people out and in. And somebody had to ride this at least once. No one. So this is a double decker. They have passengers on the lower bottom with beds or chairs if they choose, and the top is more beds to keep it from being overpopulated on a certain level, and it makes it bigger. And this was a usage of moving army supplies across the country, like the National Guard to move it across to protect the nation and keep it from running out of supplies. And this is one of the war trains back then they used in one of the wars. And this is not the U.S., this is a different country. So the type of derailments I'll be talking about is equipment failure, operational failure, and environmental incident cause of failure. This train went about 80 miles per hour on a 30 mile rail in the town. So what happened was one of the wheels came off the track when it came in too fast, and it actually derailed right before the turn, and it started to crash along the right rail. And this was due to human error. Environmental cause, like landslides stopping rail freight trains at the top left. They was delivering crude oil across, and a rock slide came by and smashed the engine. Bottom right is a passenger train, which was hit by a landslide full of trees and other debris, and it caused the train to come down a mountain. So this is a human error due to aggressive braking. When a train brakes too hard, it will crush one of the middle cabins into a little can, and the wheels at the bottom would likely come off. So this is one of the accidents that happened on the 19th of December 2017, which was early on last year, or late last year. And the train traveled 81 miles per hour on a curve, and it actually had PTC, which is positive train control, to slow down the train, and it actually just ignored it. After the news happened, they said it was not activated. So it is a human error and equipment error. Now this is the equipment failure. The wheel had cracked in one of the cycles, one of the services, and if even one of these wheels crack or break, it could cause a derailment right off the back of the hand. So I'll be talking about the vocab for certain key words in the trail industry. So the knuckles of the coupling, the knuckles is what holds the trains together, the trail railroad cars, and keeps it from detaching, like certain trains that use magnets to keep it together. PTC is, as I said before, was a positive train control mechanism for the train so it could slow down on curves and to keep from going too fast on the rails. The track geometry car is what check the rails during times where the trains are not running. So when the trains are not running, they'll be on the rails riding through with a crew of 7 people at least. And they will drop little devices to scan the tracks for faults and certain disturbing behaviors in the rails and the ground under the rails. Derailment is when the train comes off the rails. It doesn't mean that it's a crash. A crash is when it crashes into another train or it crashes to a obstacle, like it overshoots a station and hits the end of the line. An on-head collision is a crash where it hits on the head with another train, and it makes the trains explode sometimes, most of the time, because of the fuel that's in it and what it's using. So this is a date run. This is a chart rate, an incident rate run on Friday, March 30th, 2018. And the lowest accident rate was in 2012 when they had 15.24 as a rate. And that is it's a high rate, but it's also a lower rate than all the other rates. There are over about, give or take, 5,000 crashes a year with trains in any country. The highest rate was in 2014 when a lot of trains started crashing for certain reasons. 2018, where we're in now, it may end up at higher than 2014. So this is the chart for equipment failure, human factor, miscellaneous, and track and segment. As you can see, the human factor is actually larger than equipment failure, which is really worrying. And the miscellaneous is like trees and debris in the way that causes derailments. Track and segment is when the tracks are cracked or they are tampered with by other people and stuff like that. Or, they break in a certain way. Equipment failure is when the parts of the train starts to break. It'll get worn down, so they have to replace certain parts of the train. Miscellaneous and track and segment can also combine for like environmental, because if the environment starts to mess up, it will induce faults into the track and segments. So this is when a train was going to Smithsonian. As it was traveling on the first track, the driver realized that it was turning to the left on the wrong track, and number 1. Number 2, he realized it and tried to back up. And 3, he backed up, but the back wheels were still on the first track, which is the right track, but the front wheels were on the left track, which is the wrong one. And so in turn, in number 4, the train got crushed, and the roof collapsed. So the equipment was 3, track was 4, miscellaneous is 4, and human factor is a 22 for primary cause, which is really worrisome because if that's the main cause, would AI make it better, or would it help if we had more specialized people for drivers on driving trains? The accidents by track type was industrial 5, mainline was 8, and the yard is 21. The train yard is where the trains are stored, like freight trains, passenger trains, any type of train. They store those there and bring them out when they need them, to like as replacements, or they're moving them cross country to be moved to certain stations. And so what happens in the train yards is, as the trains come out, they start to move a certain way because of how many trains we move to that area. And you got to keep watching the rails because those rails have a high likelihood of cracking and having more faults than normal mainline rails. So this is a geometry train. They use this on rails when no trains are running. You will see these on the rails maybe at certain times at the last day of the month, like March 30th, February 27th. And these are the devices they drop in the bottom right. The bottom right, they drop these to measure for faults. It's better to use those to pinpoint it, and they drop those along the track as they move on. And then as they come back, they pick them up, and they review what they found, the faults. And there will be a crew of 7 or 8. So, as I was saying, with the cars have V8s, V12s, V6s, V4s. Trains go up to give or take, 28s, V26s. And they need these pistons to move that train, because trains weigh over, give it like 20,000 tons, because freight trains especially, because they move a lot of material, over 120,000 tons of material. At the top right, this is the inside of a passenger train. The inside of a freight train is different because it's more industrial than a passenger train. The bottom left is the knuckle that holds the cars together. And the bottom right is the brakes, which are similar to a car, as they use brake discs. This is one of the crude oil disasters in the town of Lac-Mégantic, in July 6th, in 2013. When the trail was traveling on the tracks, there was debris in the way. So what happened was it sent a ripple throughout all the crude oil cars, and started moving all of them at the same time. It was like a slinky. Slinky have ripples. They keep traveling through momentum. What happened was the cars had the same effect, and it just started moving as it went on, and it just tipped over, and it skidded. But the thing was, they also exploded on impact with houses and mill houses and factory buildings. So this is a trail that derailed in Paris on Friday, July 12th, in 2013. This train had a broken wheel on the bottom, on the right of the train, on the front engine. So as it came in, the wheel broke, fractured, and it also fractured the rail, and it went to the right. It killed 10 people, and several dozen were hurt or injured, and 6 people were severely injured. So I had a solution to build a suitable guardrail for trains. If they derail, it may not stop derailment, but it'll stop the destruction around the environment of the rails and keep it in check. It will cost approximately $300 million to $700 million per mile. And trains are not cheap at all. So My second solution was to build slide rails into the train on the sides above the wheels of the train to keep it on track. But it won't have wheels; it just have slides, and they can have mechanisms to use as brakes and keep it to slide. It could slide on curves to slow it down. So the problem with this was, the only problem I could see happening with these were that if you stop on curves, it may tilt because it's actually curving the whole turn. And then if it stops completely, it could bring the whole rail down. And it may cost $400 million to $800 million per mile. This one was creative, but to create wheels on top of the train and rails to keep it moving, but you can move it at a kind of an increased speed due to it being like a tunnel, but not covering the whole rail, the whole train, due to needed maintenance. So as it travels on the curves, like the slide rails, you cannot stop on curves. It will also fall down. But there's not likely going to be a need for that if you use certain types of metals to use as the rails, for rails in different sections. And it may cost $250 million to $600+ million. It depends on the type of metal that you use. So this is the magnets I was going to use under the rails to keep it on the track, but not enough to hinder the movement. So as it travels on, it builds up magnetism and it keeps it on the rails. But it also has a magnet underneath the trains to reduce the hinderment that it causes to the train and keep it going. It may cost $100 million to $700+ million, depending on the type of magnets you use. Or we can use one for non-profit, and keep it cheap. And really it's more educational, and it drastically stops derailments from happening, because if you slow down 10 miles ahead before the turn, you won't have the problem of it derailing, going too fast, or the tracks deforming because you're going too fast and the heat is coming from the wheels when it starts to break. But it may cause it to take longer on trips, but the big question is it worth it? And these are not short-term solutions at all. These are all long-term, and may take 5 years to 10 years to even complete. And the freight trains that deliver supplies, those are going to cities where if those cities don't get those supplies, there could be people starving. There could be businesses that go out of this because they don't have certain supplies. They deliver cars to people, which people may lose their jobs because they can't get their car, or they're missing a lot of different things. And this is the references where I got all the pictures and data from. That's it.